Suppose for a mystery sequence, an, we're told that an plus 1 over an is equal to n plus 5 over e to the n. Assess the convergence or divergence of the infinite sum, the series that's adding up these ans. So when we look at this, it's really clear. As soon as you see an plus 1 over an, you should sort of jump out and say, hey, it's ratio test. It's ratio test time, right? Because we're halfway there. Somebody, like, we don't have the formula for the ans, but somebody has given me the expression that I would need to set up to get this ratio test going. So, okay, let's take a look here. Rho, which is the value, it's not a p, it's a rho, that we use. So we're going to use the ratio test, but oh no, I don't have a formula for the ans. That's okay, because they told me it's n plus 5 over e to the n. Let me just double check that that's the case. Don't want to get things wrong. Yeah, we're good. Okay. So we've got this given to us. I'll switch back to the black ink here. And so, okay, as n tends to infinity, what's going on here? What's the deal with this? Well, as n gets really big, n plus 5 is going to be really big. So the top's going to get bigger and bigger. But e to the n also gets bigger and bigger. So we see, all right, if we want to do this limit properly, what we have is an indeterminate form. Indeterminate. Okay? And when we see indeterminate forms, that usually means that we've got to try other techniques that we know to simplify this limit and try and get this rho value. Okay? A really obvious one that a lot of people tend to go for would be something like L'Hopital's rule. L'Hopital's rule says, try and set the limit up again, but differentiate the top and bottom and see if that works. And if that has a value of, let's say, 3, then the original has a value of 3, and then we'll be able to calculate our rho. So we'll take the derivative, so we'll use L'Hopital's rule. I like putting the little apostrophe h for L'Hopital. That way I don't have to write every single time I want to use L'Hopital's rule. Okay? So we're differentiating. These aren't functions of x or y, they're just functions of n, but the letter doesn't matter. So the derivative of n plus 5 is just 1, derivative of e to the n is just e to the n. And now, as n gets bigger, the top is going to 1, the bottom is getting really, really, really big. So 1 divided by a really, really big number is basically 0. Okay? This is just notation. 1 divided by infinity is nothing, because infinity is not a number, but symbolically, we've got a constant divided by a really, really, really big number that should be going all the way down to 0. So since this limit exists, L'Hopital's rule says the original exists, and so our rho in this case is 0. And then we just get to conclude, okay, by the ratio test, the sum of my mystery sequence, that series must converge. And we're done.